Question 8, part 1. So relative to an origin, the position vectors of the points A and B are 2i plus 12j and 6i minus 4j respectively. So we have to write down and simplify an expression for the vector a to b. So what we'll have then is a to b, well, that's going to equal b minus a. So that then equals 6i minus 4j minus a, so don't forget to use the brackets, 2i plus 12j, and that equals, well, 6i minus 2i is 4i, minus 4j minus 12j is minus 16j. So that is the vector a to b. So that is part 1. For part 2, we're given that the point C lies on a to b such that the ratio a to c to b is 1 to 3. So that means then on that line, or that vector a to b, we've split it up into 4 parts, and one part of that is a to c. So that means a to c is going to equal 1/4 of a to b. So o to c then, well, that's going to equal o to a plus a to c. So that equals o to a plus, well, a to c is 1/4 of a to b. A to b. So that equals then, or o to a is 2i plus 12j, and then plus 1/4 of a to b, which is 4i minus 16j. So that equals then, well, 2i plus 1/4 of 4i, so that's just I, so then we get 3i, and then 12j plus 1/4 of negative 16j, so 1/4 of negative 16j is negative 4j, so 12j minus 4j is going to be 8j, so we get plus 8j. So what we need to do now then is find the magnitude of this vector, because the unit vector in the direction of o to c, well, that's going to be 1 over the magnitude of o to c times the vector o to c. So the magnitude of o to c, so work that out, the magnitude of o to c, well, that is equal to 3 squared plus 8 squared, all square rooted. So that is equal to, well, 3 squared is 9, 8 squared is 64, so 9 plus 64, which equals the square root of 73. So therefore our unit vector in the direction of o to c, well, it's going to be 1 over the square root of 73 times our vector o to c, which is 3i plus 8j. So that is part 2. So for part 3, the point D lies on o to a such that the ratio o to d to a is 1 to lambda. So that means that line there, or vector o to a, is split up into 1 plus lambda parts, and lambda of those parts is d to a. Okay, so what we know then, well, we know a to d, well, that's going to equal negative d to a. So let's just work out d to a first in terms of lambda. So d to a, well, that would be, we've got lambda over 1 plus lambda parts times our vector o to a. So therefore then, a to d, well, that's going to equal negative of that expression there of d to a. So it's going to equal negative lambda over 1 plus lambda times our vector o to a. So that equals then negative lambda over 1 plus lambda times o to a, which is 2i plus 12j. And that finishes question 8.